Hey everybody, this is Terry, and welcome to part 1 of a two-part series on my object sorting system for top-down or 2.5D games in GameMaker Studio 2 I call Grid Layers. Now, just a heads up, this part is an overview and does not contain any coding. If you feel that you are already familiar with GameMaker Studio 2 sorting systems, feel free to jump over to part 2 and we can get to coding the system I put together for you. If your game has or does look anything like it does on screen, you are in the right place. Truth is, the most important aspect of a video game is what you see. And when it comes to top-down or 2.5D games, you also have to see it correctly. In this first part, I go over how GameMaker Studio 2 does it by default, how the other systems out there do it, and finally how mine does it. My end game is we go into coding knowing what's up, and in the future, if you happen to get a visual bug, my hope is you will recognize the issue, be able to fix it, and move on with your game. With that said, let's sort out object sorting. There are a couple depth systems out there already. I have the top 3 listed here along with the one we'll be coding in part 2. In the end, they all do the same thing though. They take this and they turn it into that, but in pretty different ways. We're going to start, however, by going over how GameMaker Studio 2 does it by default. What it all boils down to is GameMaker draws the instances based on layer first and then by instance ID lowest to highest. The instance ID affects the processing of just about everything in GameMaker. Every create event, step, alarm, collision, and draw all get processed by order of the instance ID too. Some of the most common variable errors come from trying to change or read from a variable that doesn't exist yet because it's in an instance that hasn't been created. In this case, we can see where the default can cause some issues with sorting. We've got trees growing on trees and a rock that's been in a tree for so long it seems to have gathered moss. This way of sorting works spectacular and is blazing fast for platformer games or strict top-down games. However, that's not what we're trying to make. Like I said in the beginning, we're going to examine how the 3 most popular systems work and touch on their drawbacks. In a nutshell, binary lists and FC grid sort are quite fast at low instance counts of less than say 150 or 200. The problem is with the sorting. There are whole computer science university courses on sorting things because computers aren't very good at that either. Grid lists, on the other hand, found a way to skip the sorting altogether, which is why it pulls ahead of the other two at higher instance counts like 4 or 500 or more, but at a huge cost in time to process all those lists. Unfortunately, that cost is there even if you only have a few instances on screen. All 3 have a final drawback. We lose control of the instances draw events so we can actually draw them in the right order. Not only does this create a bottleneck, it makes it harder to do effects. In some cases, the entire list or grid of lists has to be run through twice just to do shadows, which of course hurts your frame rate even more. They do, however, do what they say they're going to do and get everything sorted nice and neat despite their drawbacks. From here on, and now that we have an understanding of the other systems, we're going to focus on the system I put together for us, Grid Layers. I tried my best to represent how the system looks in the simple table. Over here on the left we have the DS grid with a cell for each Y position in the room, and on the right we have a representative of each of the layer references the grid cells hold. The layer depth isn't part of the grid, but I put it in there to show what depth we assign when we made each of the layer references in the first place. When the game starts, or at creation, all of the instances have instruction to find their layer reference from the grid and assign themselves there. Using the layers, we don't actually have to sort through a list because everything assigned to that layer gets batch processed and submitted for drawing by order of the depth of the layer, automatically. We also don't have to waste any time checking empty layers, GameMaker simply skips them. What I'm also trying to show here is that only the objects that actually move along the Y-axis have to have their layer updated. Otherwise, everything just stays assigned to the layer they are on until the end of the room or game. What this means is there is almost no processing to keep things organized and looking right. I hope that this gave you a better understanding how the depth systems work and how grid layers works. I didn't want to sit here and just read everything verbatim to you that you could read yourself or say anything different from what you saw. I wanted to provide an option to print this out and reread it any time or watch again without sound and get the exact same information. In this part, we're going to go through and code my system for sorting we discussed in part 1 called Grid Layers. If you haven't downloaded the template from the thing below, please pause the video and do so. Then take a minute to look around and come back when you are ready to get started. Now this is just a heads up. This part of the video is mostly unscripted, so I am certain I will experience failures of my brain to mouth filter. If I do, please forgive me, but we're just going to try to keep going where I can. Okay, let's jump over to the room editor and have a look around. You should see this rather large room with a bunch of objects in it, just over 500 in fact. Looking at the layers, you can see that I have 3 already. a control layer at the bottom that holds the layer controller object. I put my control objects in the bottom layer because I want them processed first. If you remember part 1, we discussed how layers are processed high to low. This helps guarantee all my control objects get handled before the rest. You still have to make sure the control objects are at the top of the creation list at the start of the game if they have variables other objects need though. I have a terrain layer made up of tiles that make up the ground, and the all-important sort begin layer that has every object on it we are targeting for sorting. You will see what this layer does soon enough, but let me show you how I normally lay out my 2.5D projects. Yes, that's a lot of layers. No, we aren't doing all this. You can see the sort begin layer here, and a sort end layer. We'll be adding the sort end layer shortly, but these two layers is how I get my boundaries for the dynamic layers we'll be creating with the grid soon. Looking harder at this, you can see I don't actually use that many instances or objects, almost everything is tiles. Even though the sorting system can handle it, I still try to replace objects with tiles wherever possible. Pretty much, if it's something that can be interacted with by the player, it's an object. Otherwise, it's a tile. Take a moment and look it over if you like. It's a great system, well for me at least, but I do recommend you try to write stuff out like this on paper for your projects. It really helps keep you on task in the long haul. The last thing to call out with the room is I have a view set up along with it being set up to follow the player. This isn't always the best way to set up the view, but I wanted to simplify the project as much as I can. Over to the objects. I have my control object, a parent object, and 3 subcategories objects: static, active, and props. I actually leave object parent blank with this system because in this case I don't actually need it to have anything in it. I figure by the time you fill all the other objects in with a bunch of code, they will be entirely different. Well, they are, at least for me. Under each of those subcategories, I have a bunch of example objects, including an example of an interactive static object, which is the grass, and a basic AI that moves around the room. Let's go ahead and open those up. Now props are new. When I was working on my project, I realized the need for a hybrid object that doesn't move but needs to remain active. It's a blend between static and active objects. Okay, we will start with object layer control. If not already, go ahead and open it. Click Add Event, Create Event. I say power to, in general, as often as you can, use power to numbers for your games. It simplifies everything and pleases the CPU and GPU gods. Use them for sprites, math where feasible, rooms, backgrounds, everything. Using power of 2 numbers also helps with collisions, drawing, all that stuff. I promise I'll drop off this soapbox now, but I mean it. Try to use power of 2 anywhere. Regardless, for this particular system, we always want to try to stick with a power 2 number for our grid cell size to match up with our room sizes that are also should be powers of 2. I base that number off the player object and the AI, who all move around at 4 pixels per step walking speed. The next variable is the grid height. This is how many cells the grid holds vertically. Our room height is 2048 divided by 4 equals 512. Now this number is very, very important, and I'll show you where we use it for the system to actually work once we create the grid. Okay, let's get our layers set up. Click on the Sort Begin layer, click on the little lock, and then set the depth to 512. Now we use the lock to make sure that the depth never changes no matter how many other layers we add to the room. This is also why we need the Sort End layer. So let's go ahead and make that, then hit the lock to keep it at our depth of 0. Hit F2. Oops. Click it. Hit F2. Sort End. Click the lock. This locks it in at the depth of 0. Now, why did we do this? We set these two so that we make sure that we always have the space between where all of our dynamic layers are going to live. We also set the depth of all of our layers based on sort begin. The final reason is we want to make sure that no other layer interferes with the layers we're going to make here in just a second. So let's jump back over and start making our layers. Okay. If you look down here, the parameters are depth and name. We are not going to use the name because we're going to treat the grid cell as the name, so all we need is the depth. We calculate the depth of all of our layers based on the sort begin layer. So what this means is at the top of the grid, 0, 0, at the top of the room, Y0, the depth is the highest or the farthest away, while at the bottom of the grid, at grid height, at the bottom of the room, at room height, the depth is the lowest or the closest to us. This essentially stacks all the instances back to front or lowest to highest. Okay, let's move on. Let's clean this up a little bit first. Okay, next we're going to set up our static instances and see how they look in the room. First, we need to make a helper script that will actually do all the sorting for our objects. We're going to name it update layer. That's it. That's the whole calculation for setting the new layer for the instance. Now all we have to do to get our static object sorted is put this in the create event. It actually goes in every object's create event, so we'll do that too. Save. Here's our static object. Okay, now all we got to do is go ahead and test it out. Play. Let's hope I didn't make any mistakes at this point. Okay, and there we go. Everything is sorted. All of the static objects are at least sorted. None of our little players here are, grass on head. Maybe it's a hat. There we go. He's a king or a tree king. Okay, so that was it. That's all we need to do for our static objects. We never actually have to sort them again. Every time we create a static object, since it's in the create event, that static object will automatically shoot to its first layer. Okay, I'm getting kind of excited. Let's go ahead and get the rest of the active objects sorted out. First, let's copy this script into the create event, and then we'll click add event and step event. Okay, we do this in the end step event because we're setting this thing up assuming that the active objects are going to do all their moving and shaking in the main step or in alarms. This makes sure that the instance gets sorted to the correct layer after it does all its moving. Also, before we take another step further, we also only want or need to update the layer of the instance if he has moved up or down and he is in the room. The room because we don't want to try to create an error by trying to sort to a layer that doesn't even exist. Sorry, I gotta get organized. There we go. Okay. Let's go ahead and test this out. Yep. There we go. Let's walk through the grass. I love this. And there you have it. All of the active instances are now sorting only when they move on the Y. So right now he's on the same layer, same layer, same layer. Now I change layers, change layers, change layers. And that's pretty much how the system works. At this point, we could even call it done, but we have a few optimizations that we need to do to really make this thing get even faster and more optimal for even bigger and bigger games. We want to make sure that we take control of the things that are active and moving around in our room, and we want to try to minimize the impact on the system with having all these instances. So let's go ahead and do that. Back to our object control layer. Let's see, it's right here. Get it centered. Want it to be up here. There we go. Because we're going to do some cleanup. We want to make sure everything's organized. Okay. We use max 0 because we don't want this extra rectangle to go outside the room. So if we were at view x 0 minus the pix buffer, that would technically be negative 64. We don't want negative 64, so 0 would be the max number in that situation. Now we have to make the other side of the rectangle. Okay, and then we only need 2 more, and we're done with this part. Now we're going to use this last position to detect whether or not the view is actually moving. So this is yet another situation where we're actually going to only do an update if something's actually moving. Otherwise, everything's just kind of wait for us to move forward. Okay, let's pull that out. Oops. Back to our workspace. Now what we need is to add event, step event, begin step. We're going to do some more copying because we really don't need to retype all this back out again. Now this is where we're actually going to activate the deactivated static instances that we are going to be shutting off here in just a moment with them. So essentially what's going to happen here is whenever we move the actual view, it's going to update all of its bounding area, and then anything within that bounding area is going to get activated if it's been deactivated previously. So let's head over to the static objects. There they are. Add event, alarm, alarm 11. Okay, now we're going to use the rectangle that we just made to see if the instance is outside of the view. If he is, we will deactivate him. Since we can't see him, there is no need for us to write any of their code anyway, so let's just go ahead and shut him off and save some resources. Okay, so now we're going to measure using the bounding box of the instance. And the reason that we have to use the bounding box is because the instance activate region uses the bounding box to activate them. If we were to use their X and Y, what will end up happening is the instance activate region will activate it, and then by the time this alarm runs again, it's going to think it's outside the view, so it'll deactivate itself. So essentially we'll get this popping. We have to fix that using the bounding box. I promise that's the last big code we're going to have to do. Else, so go and get it laid out. Okay. If he is inside the view, we don't have to do anything in view. If he is outside the view, okay, so what this boils down to is every 2 seconds, this instance is going to see if it's outside the view or not. If it is outside the view, it shuts itself off. Now, the reason why we set the alarm at the end is even though the instance deactivate runs, that alarm will still hit. And so it'll kind of save its position. So when it deactivates, it'll just kind of hold on, hey, how's that alarm room speed ×2. And then when it ever gets reactivated, it starts this whole process all over again and keeps rolling forward. Okay, so static objects are done. So what we're going to do is we're actually going to copy the alarm. And we're going to go to the active objects. We're going to make a couple of small changes. So instead of deactivating the active objects, because we want to keep them active, what we're going to do is if they are in view, and then we're actually going to kind of crank up the speed of this alarm a little bit. So what we're going to do is we're going to say, in this case, I'm going to say double the speed of the view, because the view moves at the speed of the object that it's following. So the view moves at 4. So I want to say within 8 steps, I want this to go ahead and trigger again in case it's to check. It'll start to check it over and over and over again. As soon as they get back inside the view, it only checks every 2 seconds. So when it is visible, it's only checking every 2 seconds. But when it's invisible, we're checking every 8 steps. Now what this does is it allows this time as the view moves towards this object, and as he comes across the view, it'll make them visible again and allow us to see them without them popping in and out of existence. We're also going to update his end step event to say if visible, and so now we're not even going to update his layers, whether he's moving up or down at all, if he's not visible. So we're adding to this even further. So now not only does he not even update when he moves only up and down, he won't even update if he's not visible, which is also why we had to do the update layer here, just in case, because if he pops into existence and he happened to have moved, it shoots him to the correct layer right away. But we don't want this to run every few seconds. We just want it to run that one time and update himself. Okay, so we can actually take this exact same event once again, and we're going to put it in the props. Now this is the only one that the props need. Remember, they don't move around, so they don't have to update every step because they're not going to be moving. We only care about making them visible or not. So why are we doing this real quick in case it's not clear? As your game progresses and as you get further into it, you're probably going to add more and more special effects, probably change some kind of image blending or all that kind of stuff. Now, even though an instance is outside the view, its draw event is still being run every single step. We don't want to do that if we can't see them. So if we have a character that's on fire or glows or something like that, we don't need to process any of that if we can't see them. We only need to process it if we can. So that's why we're doing this. We're shaving off some more frames per second by doing this. Okay, so all we really have to do now is just some cleanup and we are done. So let's go back up to Object Layer Control. There he is, Add Vent, Other, Room End. Move it over so we can see. Clean up grid and layers. Okay, so I'm going to grab the create event. Just going to borrow this for loop, so we already have it all typed out. Global dot layer grid. Okay, that's our first cleanup. We need to get rid of our dynamic objects here. Go down to, we don't have to do anything with the statics. Now down to the active objects. Other, room, end. For these guys, it's pretty simple. So if for some reason we set this player object as persistent, we want to make sure that if he changes rooms, he gets back onto that sort begin layer before everything else is destroyed. And also we want to make sure he's going to be on that layer when he starts the new room. So remember, every room's got to have sort begin and sort end all set up the way we do here. This is just protects us from the object disappearing into infinity because we destroyed a layer that he was sitting on. I'm going to do the same thing with that one, copy event, Paste event. Okay, looks like we're done. One last tidbit. If you find that this alarm is not fast enough to change your active instances back to visible before they are in the view, go ahead and drop it to like a 4. I like to push this number so it's doing as little as possible as often as possible, but depending on your view speed, it might be moving too fast for it to react in time. With that said, let's go ahead and test it one last time. I went ahead and added instance count to the object player draw event so we could visualize the deactivations happening. You can see this number increase as we move around and then drop off again as the alarms kick in. And that's it. That's all you need to get this system rolling. You shouldn't have to make any other alterations from here. Just enjoy coding your project and it will handle making sure everything looks correct for your 2.5D game. In the end, this system met all of my needs for my project. It was fast, easy to set up, uses no depreciated features, and most important of all, it leaves the entire draw pipeline open to get your game as visually close to what you imagined when you started it. And that's a wrap. Thank you for watching. Thank you for your time. Please leave feedback in the comments below on my Twitter, or if you have any questions and need help, please go to the GameMaker forums. If you want to see more, please subscribe. Trust me, there's a lot more to come, and remember, all is well.